Hello, dear students. I have the pleasure to meet you today to introduce another part in dynamics, which is impulse and impact. Hoping you enjoy our lesson today. Let's go to the following example. Impulse and impact. The rules for impulse. I equals F times T, and here I denoted to the impulse, but F is the force and T is time. So I equals M times V minus U. Dear students, the following table of conversion can use to remember this. The units of force is either Newton or dyne times T in second equals M either in kilogram or gram times V minus U either in meter per second or centimeter per second. Now let's go to the first example. A ball of mass half kilogram is thrown towards a wall so that it strikes the wall normally with a speed of 10 meters per second. If the ball bounces at right angles away from the wall with a speed of 8 meters per second, what impulse does the wall exert on the ball? How much is the resistance of the wall? Then if the time of a streak is 0.05 second, solution. Now, when approaches wall, U equals negative 10 meters per second, and leaving the wall is V equals 8 meters per second. So, at the ball, move to the left, approaching the wall, U equals negative 10 meters per second. And in case of the ball moves to the right, leaving the wall, V equals 8 meters per second. And the impulse, its direction is to the right. So, taking the direction of the impulse as positive direction, I equals M times V minus U. M here is half and V is 8 minus U is negative 10. So I equals half times 18, which is 9 newtons. Since I equal Ft, therefore 9 equals F times half, therefore F equals 180 Newton, therefore R equals 180 Newton also. Now with another part, which is direct impact of smooth balls. Theorem. If two smooth balls collide, then the sum of their momentums never alter due to impact. Example. A smooth ball A of mass 5 kg moves on a horizontal ground along a straight line with 11 meters per second. Overtakes another ball B of mass 8 kilogram, moves on the same line and in the same direction of A. If the velocity of A just after impact is 7 meters per second in the same direction before collision, find number A, the velocity of the ball B after impact, number B, the impulse of A on B. Solution. The two balls, as you see in the figure, in one direction to the right, in direction of K, where the velocity u1 of the ball A is 11 meters per second, and the velocity u of the ball B is 8 meters per second, and the velocity v1 is 7 meters per second. Let K be a unit vector in direction of motion of both. So u1 equals 11 meters per second. Number A, since m1u1 plus m2u2 equals m1v1 plus m2v2, therefore 5 times 11 plus 8 times 5 equals 5 times 7 plus 8 times v2. So the unknown here is v2, and calculate v2, you get v2 equals 7.5 meters per second. Now number B is the impulse of A with respect to B, or the first ball to the second ball, equals m2 times v2 minus u2 equals m2 equals 8, v2 equals 7.5, minus u2 is 5, so the result will be 8 by 2.5, which is 20 kilogram meter per second, equals 20 Newton per second. For every action, there is a reaction equal in magnitude and the opposite in direction, and acts on the same line of the action. The pressure on a plane. Now we study 3 cases. Case number 1, rest or uniform motion, stability of the body, means W equal R. Case number 1, rest or uniform motion. This is the third law, means R equals P, therefore P equals W. Case number 2, upward motion with acceleration A, as you see in the figure, R upwards, W downwards, and A is upwards. Equation of motion. MA equals R minus W. Third law means P equals R. Therefore, P equals W plus MA, i.e. P is greater than W. Now we study 3 cases. Case number 3, downward motion with acceleration A. Acceleration here, as you see in the figure, is downwards. So the equation of the motion is ma equals w minus r. Therefore, p equals w minus ma means p smaller than w. Apparent weight is the reading of a pressure balance in an elevator moving vertically. If the apparent is greater than real, then the acceleration is going up or deceleration is down. If apparent is smaller than real, then accelerating down or decelerating up. Apparent equal real, then the motion is uniformly or at rest. The tension in an extensible string. If an extensible string is attached between 2 points on the force appears in pairs, action or reaction, equal in magnitude and opposite in direction, such that it appears as if each body or point tries to pull the other towards itself. Look at the figure. T to the left and T to the right, two tensions opposite in direction. Now let's go to another example. A man of mass 70 kilogram stands on the floor of an elevator, accelerates vertically by 245 centimeters per second square. Find the pressure of the man on the bottom of the elevator in each of the following cases. Number 1, the elevator is moving up. Number 2, the elevator is moving down. Number 3, the elevator is moving uniformly. Number 4, the elevator is moving down with A equals G. Solution. As you see in the figure, R upwards and W downwards, and the acceleration is 245 centimeters per second square upwards. Number 1, the elevator is moving up, so MA equals R minus W. Then MA equals W minus MG. Therefore, R equals M times A plus G equals M equals 70 times A equals 2.45 plus 9.8. Therefore, the result is 87.5 kilogram weight. Then the pressure equals 87.5 kilogram weight. Number 2, the elevator is moving down. Then MA equals W minus R. Therefore, MA equals MG minus R. So R equals MG minus A. M equals 70, G 9.8, A equals negative 2.45. Therefore, the result will be 52.5 kilogram weight, i.e. the pressure is also 52.5 kilogram weight. But number 3, in case of the elevator is moving uniformly, then the pressure equals R equals W equals 70 kilogram weight. But number 4, when A equals G, R equals mg minus A, and from number 2, A equals G, so R equals mg minus G equals 0. This case is called weightlessness. Now, let's go to another example. The ratio between the readings of the scale when it accelerates up with A equals k meter per second square and accelerates downwards with A equals 3k meter per second square is 9 to 5. Prove that k equals half gram, and if the mass of the man is 64 kilogram, find the scale reading on the upward motion. Now let's go to the solution. In case of moving up, R1 equals mg plus k, and this is equation number 1. In case of moving down, R2 equals mg minus 3k, and this is equation number 2. Divide 1 by 2, therefore R1 over R2 equals g plus k over g minus 3k equals 9 over 5. Therefore, by using cross multiplication, we can get 5g plus 5k equals 9g minus 27k. Therefore, 32k equal 4g. Therefore, k equals 1 over 8g. In case of m equals 14 kilogram, from 1 we can substitute to get R1 equals 14 times g plus 1 over 8g. Therefore, R1 equals 15.75 kilogram weight. Now, let's go to another example. In the figure shown, we notice that there is two bodies, A and B, and a string and a pool. A fulcrum raising a pan on which two bodies A and B are set such that B is on A. If the masses of A and B are 3 and 4 kilogram respectively, and the magnitude of the tension in the wire is 112 over 15 kilogram weight, find the acceleration of the motion. Number 2, the pressure of the body B on body A. Now let's go to the solution. Number 1, the acceleration of motion, we study the force affect the whole system. Therefore, MA equals 112 over 15 G minus 7 G. As you see in the figure, the weight of the two bodies A and B are 7 kilogram or gram downwards, and 112 over 15 gram is upwards. Then 7A equals 1372 over 3. Therefore, A equals 196 over 3 centimeter per second square. Number 2. The pressure of body B on body A. We study the motion of body B. Therefore, R equals MA plus G. And here, as you see in the figure, the body B and R is upwards and its weight is 4 gram downwards. So, R equals 16 over 15 kilogram weight. Now, let's go to another example. A body is suspended from the end of a spring balance fixed in the ceiling of a lift. When the lift was moving upwards with an acceleration of magnitude A centimeter per second square, the balance reading was 18 kilogram weight. And when it is moving upwards with an acceleration of magnitude 3 over 2A centimeter per second square, the balance reading was 17 kilogram weight. Find the mass of the body and the magnitude of A. Also, find the balance reading when the lift is descending with a uniform retardation of magnitude 3 over 2A. Solution. In case number 1, when the lift is moving upwards with acceleration A, T equals mg plus A. Therefore, 16 times 9.8 equals m times 9.8 plus A, and this is equation number 1. But in case number 2, when the lift is moving upwards with acceleration 3 over 2A, then 17 times 9.8 equals m times 9.8 plus 3 over 2A, and this is equation number 2. Therefore, n equals 70 times 9.8 plus 1.2 equals 770 Newton, and by dividing equation number 1 and equation number 2, we get 16 over 17 equals 9.8 plus A all over 9.8 plus 3 over 2A. Therefore, by cross multiplication, we can get 16 times 9.8 plus 24A equals 17 times 9.8 plus 17A. Collect A, therefore 24A minus 17A equals 17 times 9.8 minus 16 times 9.8, therefore 7A equals 9.8, therefore A equals 1.4 meter per second square, means 140 centimeter per second square. And by substitution in equation number 1, we can get 16 times 9.8 equals m times 9.8 plus 1.4 to get m equals 14 kilogram. But in the third case, when the lift is moving downwards with retardation 3/2a, acceleration is negative because it is opposite to the motion. So t equals mg minus a. Therefore, m equals 14, open bracket, 9.8 minus, open bracket, negative 3/2 times 1.4 to get the final answer 166.6 Newton equals 17 kilogram weight. Dear students, this example leads us to the end of our program today, and until we meet again the next week at the same time, I hope you enjoy our lesson today. I hope you all success. Thank you and goodbye.